Hello students, I have come with a new video after a long time. This is going to be revision. I thought I will do revision of some formulae from different topics as exams are coming close, right? So let me do revision of formulae from different topics. Today I have chosen 10th chapter, that is wave optics, right? See, optics we study ray optics and wave optics, and in this video, these are all short videos, you will be understanding some concepts of problems previous to the formula from wave optics. Okay, wave, we already know wave nature, right? And this is different to particle nature. Wave nature is by Higgins Principle, and particle nature was initiated by Sir Isaac Newton, right? And particle is localized in space, whereas you find that wave is not localized, it spreads throughout in all direction. And later we learnt about Einstein's photoelectric effect. With that we also learnt about the quantum theory of light. Here we are going to specifically talk about wave nature of the light. Now let us start with what are all the formulas do we have first of all, right? We will have an idea. First is, when we talk about a wave, we talk about the wave velocity, right? Wave velocity we call here c, because light waves we are talking, the velocity of light is referred usually with the c, and that is velocity of light in vacuum. C is equal to 3 into 10 power 8 meter per second. Now c is equal to nu lambda, where nu is the frequency and lambda is the wavelength. You all know that wavelength is the distance between two successive crests or two successive troughs. Okay, so this is the amplitude which we are going to take, and we are going to talk about how far, how high that is going to be, that decides the amplitude. Okay, now we know the first formula, that c is equal to nu lambda. Suppose we have, this is we call the refractive index. The first term which I am going to talk about is refractive index. What is refractive index? It is a constant. It depends on a medium to medium. For example, if I take glass, what is the refractive index of glass? When you say it is 1.5. It is referred to with the symbol n. So what is this refractive index? This is velocity of light in vacuum c upon velocity of light in the particular medium. Let us say, for example, I have taken glass here, and let me draw it a little bit bigger, and the topic which I am discussing now is refractive index. Okay, now let us take a medium like this. I am taking a glass here, glass slab, and the light is coming from the position like this. What is surrounding the glass slab is air. Okay, now this is the point of incidence. Now the ray should have gone in a straight line, instead of which it is going to bend towards normal, and this is called angle of refraction, and this is angle of incidence. Now the ray again will go further, and again there is a point of incidence here, and it has to come out. Since air is a rarer medium, it is coming to glass, which is a denser medium. It will move away from the normal. You will find that at the end of it, the emergent ray and the incident ray will be parallel to each other. When they both are parallel to each other, this is called angle of emergence, we can call it. This angle of incidence and the angle of emergence will be equal. So how we define refractive index? Refractive index of the glass slab. Refractive index of air, we can take it as 1. It is 1. But refractive index of glass is equal to 1.5. Now I put a subscript here, only G, but refractive index of glass with respect to what? With respect to air, so I will put another subscript in this side. So refractive index of air, this is with respect to air only. Okay, so how do you define? N is equal to C upon V. But is it easy to find the velocity of light? It's very difficult because you see the speed 3 into 10 power 8 meter per second. So a scientist by name Snell, okay, Snell's law you will be learning. Snell came with an idea. How can we connect this in the laboratory? If you take a glass slab and fix the angle of incidence, let us say angle of incidence is 30 degree, and what is the angle of refraction? Maybe sometime it can be 20 degree or 22 degree, let us say, right? So he found a ratio between these two, and the Snell's law, what that Snell's law says is the refractive index is equal to sine of angle of incidence to sine of angle of refraction. Sin I upon sin R, we call this as refractive index. This is same as C upon V, but you should know that finding velocity is not so easy, but finding the angle of incidence and angle of refraction, you'll find that also will lead to a constant, and that constant is nothing but refractive index. It depends on the optical density. Remember, again, when I say refractive index of glass is 1.5, it means glass with respect to air. The surrounding medium is air. Suppose if it is water, then it is going to change, it is going to differ. Okay, so with that idea, now I am going to tell you more about refractive index. Yes. So what other way? One is N is equal to sin I upon sin R. That is fine. This is Snell's law. Or also N is equal to C upon V. This is also another way of expressing it. Now, let us define refractive index. N is equal to C upon V. C is velocity. I said to you C is equal to nu lambda. Nu is frequency. So let me put nu lambda, that is in air or in vacuum, divided by, I am going to take a medium. So in the medium, I will say nu lambda dash. Now you watch carefully. When light travels from one medium to another medium, what is happening? It is bending towards normal. When it is bending towards normal, when it is from rarer to denser, what is happening? Its speed is decreasing because it is optically denser medium and the speed is decreasing. The speed is decreasing, what will happen? The amount of light, the frequency with which the light is coming, which is going to remain constant, right? That is that of the emitted waves. But since the medium is denser, the waves will get slightly compressed and wavelength will decrease, right? Keep this in mind. Now, velocity decreases, wavelength decreases. We know V is equal to nu lambda. So these two factors are changing. Or you take it like that, nu is equal to V upon lambda, right? Velocity decreases, wavelength also decreases, equally ratio, yeah? If it decreases by twice and this is by twice, let us say, then the frequency will remain constant. The frequency will remain constant. That is, the number of waves per second will remain constant, but velocity and wavelength are going to change. Yeah, keeping this in mind. So what I have done here is nu lambda upon nu lambda dash, because the wavelength in this medium is lambda dash and wavelength here is lambda, and here it is C velocity and velocity here is V. Okay, so nu gets cancelled, so you have another formula n is equal to lambda upon lambda dash. That is wavelength in vacuum or air divided by wavelength in the medium. Yeah. So wavelength, and here it is velocity in vacuum divided by velocity or speed in a particular medium. So these are the general thing, a basic one which you will be doing. It can become in the numerical, or it can be something like some thinking question. Yeah, so it can be a thinking question, a conceptual question. I hope you get a point here. Then further down, you will be learning about Higgins Principle. Higgins Principle. These are revision video. I am not elaborating more, right? I am giving you an idea. Higgins Principle. What the Higgins Principle says is talk about how to create a new wave front, right? This is the source of light. Light is being emitted in all the direction. Let us say this is the wave I have got. This is wave AB is the wave I have got. Wave front. What is this called? Wave front. So the waves are coming, right? I take only one part of it, right? And that is called the wave front. This is a spherical one. So the wave front will be spherical in shape like this. How to find the next wave front? That has been given by Higgins Principle. Very simple, right? You know that velocity is equal to distance upon time. Distance is equal to velocity into time. Here, I wanted to find out how to find the next wave front. For that, what Higgins says, every point on the wave front, acts as a source for the secondary wavelet. Every point on the wave front acts as a source for secondary wavelet. What is the secondary wavelet? The next one which we are going to talk about. Now, if I take this point and I take the distance here as r, and what is the velocity in this particular medium multiplied by time. Let me fix it. After 1 second, what is the new wave front? If I say time as 1 second, what is the new wave front? When I wanted to find out, yes, now I will draw from here, keeping it, and draw an arc like this. Draw an arc. Every point acts as a source for a secondary wavelet. These are all secondary wavelets I am drawing. Keeping this, and what is the distance I am taking? R is equal to V into T, where time is fixed as 1 second and velocity in a particular medium, homogeneous medium, same medium, velocity is going to remain same, and these are all secondary wavelets. Then Higgins says the envelope of all the wavelets, okay, the envelope or tangent drawn to all the wavelets gives you the next wavefront CD. This is the new wavefront. Okay, now I can create the next wavefront EF, GH. I can go on creating. It goes in the forward direction. Yeah, it is going in the forward direction as the light is coming, right? So what the Higgins Principle says, let us be clear. 1, every point on the wavefront acts as a source for the secondary wavelet, and from the secondary wavelet, when you draw an arc, that the particular distance r is equal to V into T, the envelope of all the secondary wavelets gives you the new wave front. This is the concept, right? Based on this, there can be 2 questions, and one is to prove the law of reflection. That is angle I is equal to angle R, and then law of refraction. Okay, law of refraction is Snell's law, n is equal to sin I upon sin R, right? So these 2 things are have to be proved, which will come in the 3-mark question. Yeah, you can read any good book for that, a reference book you will be reading. Use that book and try to learn that, because these are short videos where I cannot do the derivation, which will take a little bit extra time. Yeah, so I want to give you just ideas, suggestions in terms of exam. Okay, yeah. Now what I'm going to do, next concept is interference. Now what is interference? When two waves from two different sources overlap, right? Let me take one wave, one source of light, right, and another source of light. Okay, when the light is coming from here and the light is coming from here, they overlap in space. Yeah, and that creates alternate bright and dark fringes, right? Bright and dark fringes, and that is called interference. This I have simply said, source 1 and source 2. Yeah, two different sources cannot be. We have to get light from the single source, right? This is a source of light. Yes, from the single source the light is coming. Let us take a plain wavefront like this, and then we place a double slit. Okay, double slit. This is S1 and this is S2. Then the light will come from these two slits, and which will interfere and form the wave bright and dark fringes. You call it as fringes, or you can also call bands. Okay, so this is interference, and this is the screen, and this is the double slit. This has been studied by Thomas Young, and this is called Young's double slit experiment for interference. So what is happening here? You see, there is one slit here and there is another slit here. Slit is nothing but a small hole, right? Through this hole it is coming, so that the waves will be coherent. The wave should be coherent. Now what are coherent waves? Coherent waves are when they have a stable phase relationship. Stable phase relationship, or the path difference should be having an integral multiple. This we will study more. I will let you know about it. First you have to remember, it should have the coherent sources only can create interference. And what are coherent sources? Coherent sources are the one which has a same frequency. Frequency should be same. And number 2, stable phase relationship. I will tell you what is the relation between phase and path. Okay, this is the basic concept of it, and you can say distance between these two slits to be small d. Okay, and the distance between the double slit and the screen which you are kept here, on which you get the pattern, is called the screen here. That is fringes are being formed, and that is in this part of it, that is capital D. So this you get an idea, and the wave is having a wavelength lambda. Keep this in mind. With this I will going to tell you a point about how the interference is going to be giving you either a dark band or a bright band. What is the condition for it? Okay. Yes. Now, this is the screen, right? And this is the, let us take the double slit. This point is the middle point, the center O, and this is the point C, you can say. So you can say, call this a center O, and this you can call it as C. Slit 1, slit 2. Again, you take a single slit. This is at equidistance. Okay, this you have to be very clear about it. This is at equidistance, these two, right? The light is coming from here, and the wave fronts, parallel wave fronts are coming. Okay, the light is coming from the source. The source is here. Now, I said to you here that it is forming bright and dark fringes. It is forming dark and bright fringes. The central fringe, how is it going to be? Let us first see. Wave is coming from here, and the wave is coming from here, and we will see they both are traveling equal distance from here. Okay, so there is no path difference. The path difference is equal to 0. When the path difference is 0, the central fringe will be the bright fringe. Okay, that's fine. Then what about the next fringe? Dark fringe. But what about the next fringe? Bright fringe. How will this fringe will be bright? What should be the condition for that? Okay, now let us say this is the point P, and a wave from the double slit is coming, and another wave is coming from here. You see, I said to you, this S1 and S2 will create coherent source, same frequency and stable phase relationship. Right, now let me draw a line like this, and let me draw a line like this, and between these two there is a path difference. How will I know the path difference? Drop a perpendicular normal, call it as n. Right, see, this is this, and this distance is going to be same. S1p and np, they are same, but S2n is the path difference. S2n is the path difference. The condition for path difference to be equal to, path difference is equal to n times lambda. What is n? N can be 0, 1, 2, 3 wavelength. Then it will give you a bright fringe. Bright fringe means it is constructive interference. Okay, constructive interference. Fine. So I said to you, in between this is bright, and again next to bright, and what is going to be in between? It is going to be dark. So for it to be dark, what should be the path difference? You see, I said n can be 0. When n is 0, you find that it is going to be no path difference. Fine, condition is satisfied. N is equal to 1, that is only one wavelength difference is there. 2 wavelength, 3 wavelength, you go on rising it, and that is going to remain bright fringe. But if it is going to be dark fringe, the condition for path difference should be n plus half into lambda. N plus half, n is going to take again value 0, 1, 2, 3, 4, right, to infinity. Now n I put 0, so what will happen? Half lambda, 1.5 lambda, 2.5 lambda, 3.5 lambda. Such things with half the value will create, that is 1 and another half, then it will create dark fringe. So the dark fringe is created if the path difference condition n plus half of lambda, right? Some people used to write 2n plus 1 of lambda by 2. This is also correct, where n will be 0, then this will become go off, then lambda by 2. You see, the path difference to this point and this point, it will be half wavelength, right? If I drop a perpendicular, half wavelength, right? If it is full wavelength, it is constructive interference. If it is half wavelength, it is called destructive interference. Okay, so in this video I just introduced to you only about a concept of Young's double slit experiment, that is about constructive interference and destructive interference and path difference, what should be the condition. In the next video, I'll explain to you about phase difference, the connection with path difference, and about dark fringe, bright fringe, and fringe width, right? Thank you so much.